So, good afternoon. Thank you for joining. My name is Aart Mateboer. I'm the Global Business Unit Director for Animal Nutrition within DuPont Industrial Biosciences. And with me here is Milan Hruby. Milan is the Global Senior Application Manager. So we'll be talking to you about Nutribiosis this afternoon. But before we do so, let me just quickly show you where animal nutrition sits within the DuPont organization. So we are part of the DuPont Industrial Biosciences division, which is a $2 billion US dollar turnover unit within Dow DuPont, as I should say nowadays. Majority of our business is what we call bioactives. Bioactives entails the enzyme business, for example, food applications, detergents applications, grain processing, and of course the animal nutrition business. Then we're in biomaterials, where we make molecules from a sustainable base used, for example, in carpet fibers or in chemical processes. Clean tech has been added 2 years ago to our division, which is about reducing sulfur emission in the mineral oil industry. And the recent addition to our business unit is the microbial control unit that formerly was a Dow unit that has now been added to industrial biosciences. There is a synergy between the microbial control and animal nutrition, for example, sanitation of barns and preservation of materials. We are a global player. 50% of our turnover is in the Americas, and the other 50% equally spread over Asia Pacific and Europe. That we are a true global player, you also see how we are organized on a global scale. 2,700 colleagues worldwide, 7 R&D sites from Shanghai to Palo Alto, application labs around the globe, and the application labs very relevant for the animal nutrition business. For instance, in Brazil we do analytics on feed materials to see whether the enzymes have survived the harsh pelleting process. We do gut analysis of poultry and swine in different places of the world, viscosity on wheat-based feed materials, etc., etc. Very close to the industry, very close with our customers. The animal nutrition feed additives business is built up on the enzyme business, which we have been in for about 30 years by now. Betaine is also a component that we sell into the market, both as a methyl donor and to prevent heat stress in animals, promoting animal welfare. And for about 10 years we are now involved in the essential oils and DVMs, or probiotic as they are called in the rest of the world. Essential oils and DVMs very much focusing on the gut health. When we then look at our customers, what are their main challenges nowadays? Of course, volatility, feed cost prices. It's the daily job of a nutritionist to make sure that they use the lowest cost feed formulation. But it's not always easy to move around between different raw materials, but that's where we come in with our enzymes to make sure that the feed efficiency still is at the desired level when changing raw materials. Disease control, I think that's the most important change in the industry over the last year. The antibiotics replacement is moving much faster than everybody had anticipated 3-4 years ago, and we can play a role with our products there as well. And all of this to drive the growth, performance and consistency of the output of our customers. With the changing challenges and the changing focus, we really sat down as an organization to think, how do we approach this going forward? In the past, when everything was around nutrition, the main sales arguments were around feed conversion ratios, daily weight gains, but that doesn't cut it anymore nowadays. It's much more complex. So that's why we are introducing Nutribiosis. And Nutribiosis is basically a state which describes the interactions between nutrition, the microbiome, and the gut and the immune function. And that means that when we look at our products, we will not only talk about the feed conversion ratio, but going forward you also will hear us talk about what does it do on the gut, on the immune function, and what is the impact on the microbiome. As a company, we traditionally were involved in feed additive applications with our enzyme business, And we use that as a foundation to build the rest of the research on. For example, we're spending quite a lot of time nowadays on microbiome research, which in our research center in Wilmington is the main focus of a large group. We're really trying to understand the composition of the microbiota, looking at the beneficial microorganisms, the non-beneficial ones, and trying to understand how nutrition can move that balance. And in order to be able to do that, we also use our in-field analysis and applied research, where we look at guts that we collect in the field, poultry guts, but also swine guts, and we really analyze in the gut what changes in the microbiota when we use our additives. And not only at the microbiota, but of course also what is the immune system, how is the immune system reacting on that. And luckily nowadays technology has advanced significantly. So what we call the omics, genomics, proteomics, metabolomics, all those new sciences are helping us to progress here. And in vitro gut simulations is also a topic where we are evolving rapidly in order to help us analyze the impact of all the new additives that we are developing for the market nowadays. As I said, nutribiosis leads to a favorable state or an unfavorable state. And an unfavorable state when, for example, intestinal health is poor, and you will see a suboptimal performance of the animal. And what we are hoping for, that by using our products and our science, that we can change this unfavorable state into a favorable state, where you drive towards a good intestinal health situation, which will then result in optimal performance of the animal. Now, this might sound a little bit theoretically, but that's where Milan will step in and take over, and he will, using a few of our examples, explain to you what this nutribiosis and this broader view on health and performance of animals will bring us to. Milan.
Thank you. Good afternoon, everyone. As Aart mentioned, I would like to just go through a couple of examples of nutribiosis, favorable one and unfavorable one. And the first one here, which is probably quite close to many of us, it's looking at a specific substrate within the feed, which is called phytate. And I'm sure you've heard about it before. It is a source of phosphorus, but it's a very potent anti-nutrient. And when we look at it in terms of the nutribiosis, if I just progress here, that phytate binds very strongly with protein. Okay? When it binds very strongly with protein, it makes that protein less available for, to release amino acids for their digestion and absorption. What impact does it have on the microbiome? The impact is very much related to undigested protein in the gut, protein fermentation, maybe ammonia formation, all kind of the negative changes within the environment which can impact types of microflora within that swine intestine. And if we look at the gut and immune functions, because that phytate and protein are bound together, you see that stomach is really trying very hard by producing more hydrochloric acid, more pepsin to break that structure of phytate together with protein. And now we are releasing very low pH digester into the intestine. So what the pig is trying to do is to bring sodium bicarbonate to buffer that low pH digester. And by doing that, it really takes away sodium from the cells of the pig. And the sodium is needed for active transport of glucose, amino acids. So it really impacts that gut function, less amino acids, less energy being really available for that pig. And if we look into a favorable state, a nutribiotic state, we can look at the function of phytase or extra phi, highly bioefficacious phytase offered by our company. And what it does is that breaks that, not only releasing phosphorus, but it also reduces that binding of phytate and protein. And by doing that, there is improvement in protein digestibility. You have less protein fermentation. There are no changes in the gut microbiota. And in essence, it improves what's happening on the gut and immune side as well. So one kind of a nutritional solution, but impact all three parts of that nutribiotic state. And kind of one, not necessarily nutritional one, many producers are dealing with the swine dysentery, and especially in a situation where we are looking at a reduction of antibiotics, we see increase in swine dysentery, diarrhea, intestinal issues. And typically, if we look again from the point of unfavorable nutribiotic state, we see, for example, high energy and high protein diets not being fully digested, too much or too little of carbohydrates getting into digesta, impacting the microbiome. And there's one specific microorganism from Brachyspira species which is involved in that swine dysentery. So if you are getting more nutrients which are not digested because of a high energy diet, because of some issues in terms of digestibility, you are encouraging some of those non-beneficial microflora, including Brachyspira. And we know that Brachyspira induces inflammation, which goes again into that gut and immune function, and also impacts necrosis of a tissue. If we look at the favorable nutribiotic state, we launched 1 year ago during the Pork Expo a product called Synchras Y, which is a combination of a protease or feed protease and 3 adaptive strains of bacillus or direct fat microbials. And when we combine them and bring them in that unfavorable state due to the swine dysentery, we see increase in digestibility of fiber-bound nutrients, amino acids, protein in general, energy, and that has a huge impact on what's happening at the microbiome level. We see those adaptive species of strains of bacillus. They can furthermore utilize or produce enzymes to impact digestibility within the gut. We see reduction in protein fermentation. Again, we see change in the substrate. Short oligosaccharides produced by the action of both the enzyme and the probiotics impacting the microflora. And we see that in some of our research on lactobacillus species being increased, showing greater diversity of gut microflora, showing kind of a healthier, more mature gut microbiota. And we see increases in the fermentation of fiber, short-chain fiber, especially the butyrate, known as a positive one in terms of changing the pH and also feeding the intestinal cell. And if you look at the gut and immune function, we see from our work that we are improving that intestinal barrier. That gut is stronger. It's measured as transepithelial electrical resistance and less leakage, potentially less transfer of microflora from the gut into systemic tissue. So a couple of examples for you from a technical side. And I will give the presentation back to Aart.
Thank you, Milan. So with this approach that we are now presenting and which we will be doing in all the work going forward, we will provide the industry with the information set to make the right decisions on feed additives. So not just looking at the feed conversion or daily weight gains, but also understanding, does it promote the immune system in the animal so that you can prevent for deterioration in the performance of the animals forward. And we're also looking at means of finding early indications for that. So looking at markers in the animals is definitely part of what we're doing, and also diagnostic tools in order to get a clear view on the health status of an animal is part of the programs. And those programs will then help improve the gut health, promote the animal welfare, and at the end, what we will do it for is to improve the animal performance.